you would expect it to decrease.
That was easy.
Now, why? Hayden, stick with it. Why would you expect it to decrease its inertia?
Because it weighs less, therefore it would take less time to slow down.
Yes. So lighter objects are easier to change their motion. And that's what inertia is. Inertia is a resistance to motion change. So if it's easier to change an object's motion, it must have less inertia. Good. All right, who's feeling 2? Feeling 2?
Yeah, I think it's A.
Okay. It can be at rest. Why can it be at rest?
Because if it's at 0, it doesn't move.
Right, so if there's a net force of 0, so if there's no force to change it, then it would stay at rest. So yes, it is A. Yes?
I'm feeling 2 in this company. It's A, B, and C.
Oh, we're going with A, B, and C.
It's not D.
Okay. Why do you say B and C also?
I say B and C also because B is the only one that has an acceleration.
Okay.
And
Oh, yeah, that
net
makes sense.
force doesn't have to do with acceleration. So when it's because it can be at rest without acceleration. When it's at constant motion, it's not accelerating up or down.
Okay.
It's slowing down. It doesn't have to be. There's no acceleration or there's no force against it because x velocities don't affect y velocities.
Okay.
And there's no natural movement.
Okay. So we said A because there would be no force to get it moving.
That actually makes sense. B and C, I think.
So C, we said, was because there was no force
And it can be constant.
to change it. So it stays constant. Good.
And B.
B is the one I want to look at. So you're saying it's slow. So you're talking about, let me make sure I'm not putting words in your mouth, Cannon. But you're saying something to the effect of like, you don't have to do anything to an object to make it slow down. It just slows down on its own. Is that kind of what you're saying?
Yes and no. 'Cause,
Okay.
Like, I was thinking about like a car, right?
Yeah.
Like a car naturally slows down. There's like air resistance.
Yes.
Is that-
So that is a net force.
Oh, so no.
So it's not B.
So
So it's not B. And the reason it's not B is because of what we just said. Air resistance and friction will slow it down. Those are net forces. So there is a net force if we're slowing down. And likewise, when we're speeding up, if we hit the gas on the car, that's a net force in order to speed it up. So it's these two, at rest or at a constant speed, because there would be no force to get it moving. I should be more specific. There's no net force to get it moving, and there's no net force to change it. So if there's no net force, then it'll just keep doing what it's doing.
That makes sense.
Good. Awesome. All right. Let's rapid fire this sucker. What we're going to do is I'm just going to pick a group. Just yell out what you think it is, true or false. That's all I need. The goal, we're going to try to get 50% of them right. Okay? We're going to try to get 50% of them right. So far, the other two classes got 50%. I have faith in you guys to get 50% or better right. We're going to start in the back. Okay? Back left. Inertia is a force. True or false?
true. False.
Oh, man. You got some pushback on that one. All right. Second one. Second group. Inertia, it shouldn't say which. It should say inertia keeps. So inertia keeps stationary objects at rest and moving objects in motion at a constant velocity. Second, the middle table over here now. True or false? What are we going with? Isaiah, what do you got? False?
It's true.
Okay. Up here in the front, inertia brings all objects to rest. Okay. Over here in the front, all objects have inertia.
True.
Okay. In the middle over here, a more massive object has more inertia than a less massive one. True, 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 false, true, true, false, true. Okay. Back. Fast-moving objects have more inertia than slow-moving objects.
Yeah, that's fine.
True? Okay. All right, we'll just shout out these last ones. Whatever I hear the most of, I'll pick.
False.
Okay? An object would not have any inertia in a gravity-free environment.
False.
False.
Definitely false.
Inertia is the tendency to resist motion.
True.
Ooh. Ooh.
Definitely true.
False.
True.
The truths, I got more truths than falses. Okay.
Oh, shut up.
Be quiet. Be nice. Both of you be quiet and be nice. All right. Inertia is a false. Inertia is a force. That one is false.
No,
I'm the best. I'm the best in the world, best in the business, best there ever will be.
Are you the best around? Nobody's ever going to get you down. Okay. Here's why it's not a force. So first of all, I'm being really picky on these. I'm being really picky on the wording. Inertia is not a force. Forces cause change. Inertia does not cause a change. Forces have to be able to cause a change, and inertia does not. So inertia is not a force. Okay, inertia keeps objects at rest or moving at constant velocity. The only thing that can keep things from doing stuff or keep things doing stuff are forces. Inertia is not a force, so this one is false. Inertia does not keep things at rest. Inertia is the explanation for why an object wants to stay at rest. But the reason it stays at rest is because there's no net force. It stays at rest because there's no net force. It doesn't stay at rest because of inertia. So that one is false. Inertia brings all objects to a resting position. That is false. Inertia does not make things do stuff, so it does not bring it to a rest. So that one is false. All objects have inertia. That is true, because objects have mass. More massive objects have more inertia than less massive objects. That is also true.
Oh, we got them all right.
Okay? Fast-moving objects have more inertia than slow-moving objects. That is false. If you said true, you're thinking of momentum, which we haven't talked about yet. Momentum does have more for objects moving fast. You're thinking it's harder to stop fast-moving objects. No, it's not harder to stop fast-moving objects. You just have to change fast-moving objects more. It's not harder or easier. You just have to do more change. So if you make the amount of change the same, then fast and slow objects are the same. An object would not have any inertia. That is false. You would have inertia even in a gravity-free environment. So you would not have inertia. That is false. You would have inertia. Inertia is mass, not weight.
So we only missed two.
Oh, you got one more left. Inertia is the tendency to resist motion. That is false.
Okay.
Is the tendency to resist motion change? Tendency to resist motion change. So you got 5 out of 8. Not bad. That was also period 3. 5 out of 8. Not bad at all. All things considered.
What's the highest?
I had one group get 7 out of 8 one time. I had one group get 7 out of 8 one time. That's pretty good. But usually classes get 4 out of 8. Because some of them are, there's 3 that are pretty easy. All objects have inertia. That's pretty obviously true. A more massive object has more inertia. That one's pretty clear. And then usually groups will get either C or F or both right. And then it just depends on the rest of them. Yeah, A is very tricky. H is very tricky. B is very, very, very tricky. Because I'm being super, like, the word I'm being picky on is keeps. Right? Like, that's a really minor word for me to be picky on. On this one, it's missing a word, change. Right? That's the only thing it's missing. So, anyway, good job on those. Let's just look at practice 2. We're not going to go through it yet. I just want to talk about it real fast. So on practice 2, we're going to do this next time. Then I need to stop talking or I'm not going to have a voice the rest of the day. I know, it's already starting to get gravelly. So all you're going to do on these is you're going to find the net force. So net force is where you combine the forces together in a given direction. So what we're going to do is we're going to put the forces together and figure out what the total force is. But just like in last unit, we have to do the x's and the y's separately. So we'll find a y net force and an x net force and figure out what it is. We'll do the same thing for all 4 of these first ones. And then on these bottom 4, we're going to have the net force, and we're going to use the net force to figure out what the missing values are. Okay? So that's what we'll do for that next time. So that'll be what we work on next time. We'll do that in practice 2. We'll also jump back into notes 1 to finish those up, and then we'll go from there. Head on back to your seats.
What about practice 1?
Huh? We will finish practice 1, but practice 1 is over the second law also, and we'll do those laws first. So we're going to do practice 1 on the front page, and then we'll do the notes, we'll do the second law, we'll do the concept.
Yeah, thank you. I was there. Well,
You always do.
I mean, I remembered last time.
It's because I reminded you.
Yeah. And I take the L this time.
Oh, yeah.
Can I get candy for participation, though?
Nope.
Wow.
One handful. No scooping. It's got to be the claw.
Did you go trick-or-treating?
Yeah, you got to figure out where the good spot is. There you go.
Did you went trick-or-treating this year?
Nope. No, you can have it. What am I kidding? I don't want candy.
Wait, did you went trick-or-treating Monday?
No, my kids did.
You didn't go with them?
So it's no scoop, just the claw.
Wait, you didn't go with them, though?
My wife went with them. There you go. No, it's not your turn.
So you just hand out candy?
I stayed and handed out candy with my 2 oldest. My 2 oldest wanted to hand out candy, and then the 2 middleists wanted to go trick or treating, and then I took the youngest one trick or treating just to like the first like 8 houses. So like we went trick or treating just a little
But it
bit.
was raining that day.
It wasn't raining when it was trick or treating time, at least not by us. But yeah, we just. The little one wanted to at least like try it, and we didn't want her to go very far, just because like
Kids.
she only gets so much out of it. She's not going to remember